Once you have the correct valve for the project, you need to first excavate and then clear the area where the valve will be installed. In this video, we're going to be breaking down the installation of a valve manifold. Now, there's a lot of things that go into a valve manifold, and depending on your territory or region, this might look a little bit different. We're doing schedule 40 PVC all the way through to the lateral lines. If you're in the Midwest or if you're in a climate that uses polyethylene primarily for lateral lines, you may still be using the PVC schedule 40 as the main line and polyethylene as the lateral line. So as I start this installation, I'm going to thread Teflon tape on any threaded fittings. We're going to apply that, and that's going to create a better seal between the two plastic fittings. When you apply the Teflon tape, make sure you rotate it around the fitting in the way that the fitting will rotate into the socket of the valve. This will help keep the tape from backing off as you thread it in and bunching up inside the fitting, causing a poor connection. Once we've applied the Teflon tape, let's thread it into the valve. Hand tight until you get it as far as you can with your hand. And then take a pair of pliers and give it another quarter turn rotation. Right here, make sure that you don't use the solenoid as a leverage point. Make sure that whatever you're using to grip the valve is not applying any pressure to the solenoid, because that can cause issues down the road. So now that we have Schedule 80 nipple applied to the valve, we're going to cut it to add a ball valve. And the ball valve is going to give us the ability to isolate this valve separate from the rest of the system, so that if there's an issue on that zone, you can shut it off and come back to repair it without having to sacrifice any of the landscape on the rest of the system by shutting down water to that. So now that we've cut it, we want to leave a little bit of a gap between the ball valve and the actual valve itself and the threads, so that we don't get glue on the threads or into the valve. I'm going to measure it here to make sure that we stay consistent through our valve manifold. In this case, we're installing 2 valves, but sometimes there's more. So make note of the measurement that you took on the cut of the first nipple and apply that to the second valve for this manifold. I use the ratchet type cutters to cut through this pipe because for me that's the easiest when you're working on 1 inch. Here, after you've made the cut, I would recommend deburring the pipe. And you can use sandpaper or a deburring tool like you'll see later in this video. Shame on me for not applying it right now, but it's better to say it and let you guys know that that's a common practice. So we're going to use primer. This is PVC primer. And it's purple so that it's easily identified that it was used. This is common for inspectors to come back and look for purple along with the glue itself to make sure that you properly primed and glued the fittings on the main line. So make sure you get the primer a little bit further up the piece of pipe so that it can stick out beyond the socket and it can be seen by an inspector. Now apply your PVC solvent cement, often referred to as glue. Give it a generous amount so that it creates a good seal around the entire fitting. For proper practice on gluing, visit manufacturers' sites of PVC solvent cement and primer. They have videos that show you the whole process of properly gluing and fitting pipe. Also make sure that when you are gluing the fittings together, you put the primer on right before you apply the solvent cement. The primer is actively breaking down the compound of the plastic so that fusion can be made between the two pieces. So you're actually not gluing the pipe, you're fusing the two pieces of PVC together. The solvent helps that process, but the primer gets the plastic ready for that fusion. So you're actually making them one piece. And that's important to make sure that you glue right after you prime so that the primer doesn't dry and lose that compound breakdown. Once you slide the fitting on, give it a quarter turn to make sure that that PVC solvent is spread out evenly over the piece of pipe, and line it up so that it's pointing straight up on the valve manifold. Now after you've glued, wipe away the excess bead around the outside, because what can happen is that can build up and actually weaken the pipe right there and also cause it to not evenly dry. So manufacturers always recommend that you wipe off that bead. Now we're going to measure out the 90-degree connection down to the main line. I'm using a 90-degree connection in this case so that I don't have to cut the valve box. So as you can see, when you apply the primer, it starts to remove the lettering on the pipe. This is actively breaking down that thin layer on the outside and opening up the pores of the pipe to fuse together. So make sure that you put an even coat all the way around on both the piece of pipe that you're gluing in and the fitting that it will be glued into. Now apply a generous amount of glue to the inside of the fitting and on the outside of the piece of pipe. Once it's applied evenly, push the pipe into the fitting and give it that quarter turn. In this case, you'll see that I'm pointing the lettering straight up from the fitting. It's common practice when installing mainline and laterals to point the lettering on the pipe facing upright so that the inspector can see what type of pipe was used and to make sure that it matches the plans as called out. It's good to get in the habit of gluing it this way, even if you're not going to have an inspector review your system. It's just good practice. So now I'm going to make a measurement on the piece of pipe where I'm going to cut so that we keep it consistent again with the valve manifold installation and that the valves are at the same length from the 90-degree elbow. It's good to remember that it's better to measure twice and cut once in these cases. We don't want to be wasting resources, fittings, glue, all of those things. We don't want to have to run back to the store to buy new parts because that is a time suck and it costs a lot of money. As you see, we're applying the primer again to the ball valve and the fitting. Now, don't put too much primer or glue in when you're gluing the ball valve because this can get into the rotation portion of the ball valve and create it to lock up or seize and be rendered useless. So set that aside. We're going to do the second valve. And again, we want to match that. Here's that tool that I was discussing earlier. We're deburring the outside of the pipe because if you don't deburr the outside of the pipe, what can happen is if your cutters are dull, they'll create a lip on the end of the pipe that will create a squeegee effect that will push the glue out of the socket and into the pipe. That will create a lack of surface coverage for the glue, which will make the fitting fail or not fuse correctly. As you can see, the process is pretty much the same here. Just keep in mind it's really important to use that primer and PVC solvent cement combo on the main lines. A lot of people will argue that red hot blue glue is sufficient, but I would recommend that on the laterals over the main line. This is always the best practice for fusion with a heavy body medium set cement. So again, measure twice, cut once. We're going to match what we did on the previous valve using our ratchet cutters. So now repeat that same process that we did earlier for applying the Teflon tape to the nipples that'll be on the downstream side of the valve. And we're repurposing the other half of the nipple that we cut off on the mainline side. So we're able to repurpose one nipple for both the upstream and downstream side of the valve. And you're going to do the same process. Thread it in, tighten it hand tight, and give it that other quarter turn with the pair of pliers. Again, don't grab onto the solenoid and use that for leverage. Either put the valve in a vise or hold it with another set of pliers. It's important that you don't over tighten these because it can cause the body of the valve to crack. And you may not notice it at first, but it will fail over time with the stress of heating and cooling from the weather. You'll get used to how tight it should be after a few more installations. It's something that kind of comes with feel, but it's definitely important not to bottom out those fittings into the valve as they are tapered. And the more you thread it in, the more pressure is applied to that fitting and it's likely to crack. So we're going to measure out to where the union is going to go. The union is a device that's added into mainline installation or valve installation sometimes to make replacement or maintenance easier so that you don't have to cut the valve completely out and rebuild it. You can simply pull back the union nut by unthreading it and giving yourself a little leverage to unscrew the valve from the mainline. And if you're using the same valve, it should go back in nice and easy. You'll have to unscrew the downstream side nipple with the piece of union that's left over, thread it into your new valve, thread the new valve onto the main line, and then reapply that union nut so that you have a good watertight seal and that it's back in place. The union also has an O-ring inside of it that helps create the seal between the two sides. So make sure that if you are doing maintenance on a union, does not fall out. It's going to be important to make sure that stays in place to create that seal. So again, we're going to measure this to the same size that we just did the last valve to make sure that we have consistency throughout our valve manifold. Deburr to make that good connection. And repeat the process that we did on the last valve. Now we're building the valve manifold mainline tees. These will be pointing straight up where we connect the mainline side of the valve to allow water to pass through the valve to the lateral side. I like to install the tees facing up so that they go straight up into the valve box without having to cut it. Now make sure that when you cut this piece, that the tees are far enough apart that the valve can be spun off, either with the solenoid on or by removing the solenoid, so that that union can be used in the future for maintenance or repair. Now we have our tees separated far enough apart to maintain the valves in the future and be able to get it off. We're going to end the line here, as this is the last valve manifold in the main line, with a cap. So we're going to leave ourselves a little bit extra main line here with a cap on the end of it so that we could add a valve later. This makes it easier to just cut in a new valve or extend the main line and continue it on to a different part of the yard without having to cut out this manifold and start over again. So instead of putting a 90-degree angle on there, put a T with an extra piece of pipe and a cap on it so that it can be cut and added onto later. So now we're measuring and cutting the mainline connection piece. This is going to be the mainline piece that runs from the T on the mainline side up to the 90-degree elbow that will go to the valve itself. We're going to cut these at the same length so that both valves ride at the same height. When you're installing the valve, it's important to look at what type of valve you're installing and if it's going to be a micro valve for drip or if it's going to be just a standard valve for sprays or anything like that. You want to make sure that you have enough space from where grade is on the site to the top of the valve inside of the valve box. So it's important to measure out the height of the valves when you're installing them. It's not just like a, hey, whatever's the right length or right size. You want to make sure that it's going to fit in the valve box without the lid hitting the solenoid or pushing down on the wires. But you also don't want it to be too deep in the valve box either, because what will happen is if it's too deep, dirt will come in from the sides of the box and it will be unserviceable. It'll fill up over the top of the valve. Rodents will enter. So it's really important to get the sizing and height right of the valve when you're installing it the first time. So you want to create a space that's safe for the valve that's going to prevent rodent intrusion. And that's where we'll look at the way that we're backfilling the valve box and setting it when we get to the portion where we're going to then set the valve box and backfill. The other thing to remember is it's important to look at local codes and regulations to see how deep the main line should be, as well as the lateral lines. So when you're cutting this, you want to make sure that the main line is deep enough, first of all. And then second of all, depending on whether or not you're going to use 45s or 90s is going to determine the size of that riser that you're going to have from the main line to the valve connection. So in this case, we're not going to have any drip valves with filters or pressure regulation or anything else that might stick up a little higher than the valve. So we're going to cut them both the same height and we should be good to go. Now you'll see that I hold the fittings in after I glue them. This is important to make sure that you hold the fitting long enough for it to set so that you don't have any pushback from the socket, because what will happen is when you slide it in, it will create almost an elastic tension where that pipe will want to back itself out of the fitting. So make sure that you hold it in long enough for the fitting to set in and for the glue to lock up for handling purposes. This may be different in your neck of the woods. In Southern California, it's typically pretty warm, so it sets pretty quick. But if it's cold and dry, it may take a little bit longer to set, so you may want to hold it just a little bit longer. So if you are in a climate that's colder, make sure you hold that on a little bit longer. So we got our first valve glued on to the riser here. As you can see, the manifold is not glued into the main line yet. I was getting the valves set up here first, and then what we'll do in this situation, because we have the end of the line, I'll put both valves together, make sure they're straight, make sure they're glued on tight, and then I'll cut the main line and add that later. When I was installing valves regularly, I would do this in a way where I could build it on the back of my truck or in the shop, and then bring all of the manifolds to the site. This just saved a little bit of time on site and was giving me the opportunity to be quicker in my installation practices. This might not be the right solution for you, but it was a helpful tip and trick that I used when I was doing it. So here, now that we have the valves side by side, you can see it's the end of the line connection. We will measure out where we're going to add it to the main line, and then we'll go ahead and cut this main line, get the valves glued in, set, and then we'll start doing some wiring. And then once we have the wiring all set up and it's tested, we will put the valve box on and we'll be ready to rock and roll. So stay tuned for that process. So right now I'm cutting into the main line. The opposite side of the trench are the two laterals that we'll be feeding with the valves. We'll come back to those later to cut those and add them to the valve. But for right now, we're going to cut that main line. We're going to deburr the end of the pipe. And then we're going to go ahead and glue that manifold right on there. Now this connection is very crucial because you have both valves downstream of it. So if there is an issue with this connection and it leaks, then you have to cut out that whole manifold and start from scratch. There's no rebuilding it. Otherwise, everything gets really messy with a bunch of fittings. The sizing doesn't fit right in the valve box. So take your time and make sure that this one is done correctly. At this point, you can eyeball it for the levelness of the valves, or you can bring a level with you and actually level it out to make sure that it's good to go. Now I pre-measured the height of that to make sure that the valves were not going to be above grade when they're glued in the valve box, but that they will sit comfortably in the valve box safely with the practice that I'll show you later for backfilling the valve box to ensure that no dirt gets back in it, no animals can intrude in it, and it's easy to access and maintain later on. So now we're going to build out the lateral side. I'm measuring the distance from our first station lateral to the valve. That way I know what size to cut the pipe, and then we'll add the fittings on and make the lateral connection here. Now you don't want to measure these ones exactly the same because you have the second station lateral a little bit behind the first one. And if we can keep them laying flush or flat, this is going to be a lot easier to maintain later on. If you have to come back and work with this valve at all and dig it up, you can easily see and identify which valve goes to which lateral line, and you can maintain them. You can cut them and fix them, or you can add in pressure regulators or check valves later if need be. This is just a best practice to keep things clean and tidy. Now again, you may be using a barbed end or a barbed adapter right now if you're doing polyethylene pipe. Since we're doing PVC, all the connections are going to be glued all the way through. And we're going to keep using the heavier body cement here with the primer just to keep the installation going smoothly and to ensure that we have great connection. Like I mentioned before, if you did want to use a blue glue or something that was a little bit faster setting, the lateral side is definitely the place to use that. Another tip to remember is when you're using ratchet cutters, make sure you have a sharp blade. You can sharpen your blade, but it is a very temperamental piece of equipment, and a sharp blade is going to be absolutely crucial for cutting the pipe, especially if you're using class 200, because there is a crushability factor in class 200 as it's thinner walled. So as you start to cut into those things, if you see the pipe bending too much or squeezing too much, you want to loosen up, do a slight rotation with the cutters, or replace the blade to make sure that you have a nice, clean, sharp blade for making really nice cuts. In this case, I put a brand new blade on here, so we're cutting through this Schedule 40 like butter. Another thing to remember when you're gluing is that if primer sits in a socket too long, it can actually start to eat through larger layers of pipe. So if you have a pooling of this primer, it can actually start to break down the compound of the piece of pipe. And the issue is you'll start to get pinhole leaks if that gets too thin over time. So make sure that you don't have pooling of the primer material, as it can be an issue in the system later on. Now I'm about to make the connection from the lateral line to the union on the valve. As it is now, it's going to be really tough to rotate that piece of PVC into the union when you're gluing it. But a tip that you can use is loosen up the union, and you can actually rotate the piece of the union to create a cycle turn on that piece of pipe to make sure that you get that good even coverage of solvent cement. So as you can see, I'm taking it off. I'll make the glue on there. I'll prime the piece, make sure it's good to go. Another important thing to remember when you are gluing the union onto the valve, the union nut should be on there. I like to put it on the valve side so that when I take the valve off, I can put it back on and I don't have to worry about how much distance I have between the union and the valve box, because I have enough room for the union to unscrew the nut and then pull it back towards the valve, and then the whole valve comes out as well. So this is a good practice to make sure that the nut stays with the valve and that you have room to pull it back off of the fitting when you're taking the valve off of the main line for maintenance. So here we push it on, we rotate, we make sure that we don't have any glue popping out the end of the fitting where my hand is. And then we have a nice clean gluing here, and then we can reattach that union. Make sure that the O-ring is still in place in the union, because that's what's going to be creating the seal when you tighten down this nut. And then we're going to follow the same steps for valve number 2. But like I said, we're going to cut this one at a different length to make sure that the two pipes, the two lateral pipes, stay side by side. So the reason I put the tape measure inside of the union is to measure from the depth of the socket to the piece of pipe, so that when we glue the fitting to the piece of pipe, that the piece of pipe is buried fully into the fitting and seated at the seat line. Now it's important to fully seat the piece of PVC into any fitting, because fittings are tapered, and as you push it in, you're going to get the most PVC to PVC contact when it's completely buried into the socket. which is also why we want to cut that piece of pipe as straight as possible. The straighter we cut it, the better the seating is going to be in the PVC and the better union and joint you're going to get with the fusion of the two pieces of plastic. Something to remember here when you're gluing the fittings in is to make sure that the glue is the proper viscosity. If you have any clumping or any highly thinned glue, make sure that you replace it and you start with a fresh can. The worst thing that you can do is go through an entire project with old glue that is not going to create as good of a connection as a new bottle of glue and then have failures down the road system-wide. I've utilized the blue quick daubers, which the can comes with a built-in dauber, but these are nice because they create an instant seal when you put them into the jar, and it's also easy access and helpful for rapidly gluing and doing a big job like this. Once you've made sure that that O-ring is in place and you seal the union back up, it's time to connect the wiring to the valves. So I'm taping the wiring to the side of the valve manifold just to make sure that the wiring stays up on top of the valves when we backfill with gravel. We don't want it to get buried underneath the valve box or underneath the gravel, so we'll keep it right at the top and we'll just do a little tape on the inlet side of the main line to just keep the wire accessible for us. So now that we have our wire in place, we have to wire it into the valves. And to access the wires on that fresh cut, use something sharp to cut open the sheeting on the wire so that you can pull back the outer jacketing. Then you'll find a little white string inside of all of the wires. This can help you pull down and cut open the jacketing of the wire. So the area where you cut the wire, it's important to cut back any excess wire that was at the tip of that where you cut the jacketing back, because if you accidentally nicked a wire, that can be an issue in your system forever and ever. Water intrusion into the wires will create issues with communication. It can cause shorting and it can cause system failure. So it's important to make sure that you have clean wires. As you can see, I just cut it back to where I had used my sharp blade to cut back the jacketing, and now we have good wires that were cleanly exposed using the wire jacket cutting string. And we'll expose our white wire for the common, and we'll use the green wire and the yellow wire for this valve manifold to wire back to the controller. Then strip each one of the wires back about 3/4 of an inch to give yourself enough room to make the connection with the valve wire. Here on the valve wire, you're going to have 2 wires coming out of each solenoid. One will go to the common and one will go to the station terminal in the controller. It doesn't matter which one when you're talking about AC control. There's no polarity in AC that would cause this not to work correctly. So choose one of the wires from each of the valves, put them together, and wire them together with the white wire from your multi-strand cable. These are sometimes called the neutral wire or the common wire. If you're installing a DC or battery operated controller, you're going to need to follow the polarity on the DC latching solenoid. One's red and one's black to make sure that it operates correctly. So get all your common wires together in a bundle. Some people will pre-twist, some people like to use the wire nut to twist. In this case, I'm going to pre-twist, and then we're going to add the wire nut onto the cable. I cut it there so that every wire is the same distance from where the coating is cut to the end of the wire connection. We're going to be using DBOB wire connectors. These are waterproof connectors from 3M. And we want to make sure that when we put the wire nut on, we have a good solid connection where all of the wires are touching and well fastened inside of the connector. Now we're going to take and we're going to wire the valve on the right to the green wire and the valve at the bottom of the screen to the left to the yellow wire. You'll see that I pre-twisted the solenoid wire as it's a multi-fiber stranded wire. I twist it to make sure that it's more of a solid connection before you twist it to the station wire going back to the controller. Again, you'll see that the insulated coating is cut back to the same length on each one, and I cut the tip off to make sure that they were consistent. Now we'll twist on the wire nut and give it a nice vigorous twist to make sure it's nice and tight on those wires. We'll grab the wire nut and try and pull the wires out to make sure that they are fastened securely in the connector. And we'll do the same thing here for the yellow wire that's going back to the controller, and that is the lower valve on the screen. So again, in conclusion, to sum that back up, one wire from each solenoid is combined together and wired onto the common wire, which is the white wire in this case. And the other wire on the solenoid goes to the station terminal in the controller. So one wire from each solenoid is together. The other wire on the solenoid goes to its own wire lead back to the controller. So now that we've double checked to make sure all of our connections are nice and tight, we have our yellow wire, our green wire, and our common wire. We'll check at the controller to make sure the communication is good, and then we'll come back and we'll add our waterproof connectors, as you see in this scene. So the blue tube is filled with a waterproofing gel that makes sure that this connection is watertight once applied and stuck all the way to the bottom of the tubing. There are little wings on the wire nut that line up to grooves inside of the connection tube. Line those up and then push that connection all the way to the bottom of the waterproofing container. If it becomes too difficult to push it down using just the wires, you can use an external source like a landscape flag or a thin piece of sturdy wire. You'll see looking in the top here that the gel has covered all of the wire and wire connection, and it's now waterproof. When you have the wires in place, close the lid, creating a tension relief to make sure that that nut does not come back out of the tubing. Make sure it snaps on both sides and creates a tension relief on the wires that will prevent those from coming back out. Repeat this step for all three of the connectors in this valve manifold. You'll see in this case that it was too difficult to push the nut all the way to the bottom with just the wires, so I've used a landscape flag to push it down the rest of the way. You don't want to use something that's too big, like a screwdriver, that will actually pull the gel back out of the tubing and render it non-waterproof. So you'll see that the nut's all the way to the bottom on both of those, and we'll repeat the process for the yellow wire. So we'll use that landscape flag again to make sure that we can get it all the way down to the bottom, creating a good waterproof seal. Snap the cap on the top, create tension relief on the wire nut. It's clicked in place, it's not coming out, and we have a good waterproof connection on all three connections here. As you can see, we got the nut all the way to the bottom on all three, and we're good to move on. You'll see here is the bleed screw on the valve. This is a way that we can manually activate the valve, as well as a quarter turn of the solenoid. Either of these options are good for manually bleeding the valve to make sure that the water is flowing properly through the system and that we are flushed on all of the lines before we put the sprinklers on. So we've tested both of them. Water flows cleanly through. They activate, they deactivate, they close and open perfectly. And we are good to put the valve box on the manifold now. So we'll bring the wiring back up to the top of the manifold here so that it is away from all of the gravel that we'll be putting in the bottom of the box. We're going to use a combination that I like that includes brick support as well as landscape fabric to prevent root intrusion and gopher or pest intrusion, and then backfilled with gravel to ensure that it has good drainage in the bottom of the valve box. Now we'll get the bricks laid, the valve box on, the gravel backfill, and your valve manifold is complete. Thanks for watching. I hope this was helpful to go through a more in-depth process of the valve manifold installation. For more information about our training and other products, visit hunterindustries.com. If you'd like more information on our training site, visit training.hunterindustries.com. Thank you.